Okay, ladies and gentlemen, so welcome to lesson number 25, part 2, where we're going to be talking about the disadvantages to indexing, when specifically to use indexes, because there are certain times when you should and shouldn't, and we're going to talk about some of the types of indexes that you can use within MySQL. So let's dive right into it. Now, to talk about, we talked about the advantages. Those are the advantages of using indexes. The advantages are you get faster searches and faster throughput to find what it is that you're looking for. But now there's downsides, obviously, to using index. So I'll speak briefly about that. With indexes, this particular index maintains the data in sorted order, but it requires extra work once the data is actually inserted. So if you're inserting information into the table, the transactions table, you can imagine that since it has to maintain the data in a sorted order, there is extra work that's required to insert that row. So let's go back. Let's say we were to insert another transaction and the value is somewhere like, $200 or something like that. It can't just put the $200 transaction onto the end of the table. I mean, that's what's going to happen. It's going to put it onto, let me go back again. It's going to take a transaction. It'll be transaction ID 17. It'll be for the amount of whatever, $250, and it'll, store all that stuff. But there's more to it than that. If we did not have an index, then we would be done. But since we have an index, now it needs to go and update the index on the amount column because we've inserted a row with obviously some data in the amount field. So now we need to insert the $250 value somewhere inside of our index. So there's extra work that's required to figure out where that extra row needs to go inside of the index on the amount column. Okay, so that's where what you need to realize is that inserting data when you have an index on one of your columns is going to take more time because there's extra work that's required to maintain your index, right? Because if you just kept on tacking on fields at the end, then you wouldn't have sorted stuff anymore, and it just wouldn't work anymore. So this means that having index on the amount field will slow it down. Unfortunately, adding indexes leads to diminishing returns. So or adding additional indexes leads to a diminishing return situation. So you would think that, well, why wouldn't I just index every single column in my database table? Therefore, everything will be really fast. Well, for every time you add a new index, the insertion falls even more. The time to insert, I shouldn't say falls even more, goes up even more. So I forget the exact figures, and there was some, bunch of tests that were done. I forget one gentleman, he had sort of laid out roughly what some of the figures that he saw were sort of going on about. So, for example, he had a table with no indexes, and he was able to insert 100 rows in 1 second or something like that. Okay, so it was always with a constant time frame. So in 1 second, he was able to insert 100 rows, and then he inserted one index. He created an index, and then he tried to insert as many rows as he could in 1 second, and it fell from 100 to something like 85. Okay, not too bad. That was about a 15% hit on the insertion optimization and whatnot, the insertion abilities to get new data into our table. And then he added a second index, and it fell from 85 to like 50 or something like that. It wasn't that dramatic. Maybe it was 60, but there was an even bigger drop in the amount of optimization on the table for being able to insert new data. So for every new index you add, the ability to insert data falls not exponentially, but it definitely gets worse and worse and worse in a diminishing returns type of fashion. Okay, so you cannot go crazy indexing all of your columns. Do not ever index every single column in your table thinking that it's going to help you out, because it won't. And the other thing is that indexes take up a lot of extra space. Okay, because it has to recreate data in new tables that you don't actually see, but those tables absolutely exist, and it will increase the size of the database. So a lot of you might say, well, who cares if it takes up a lot of extra space, because space is not expensive anymore. Space is cheap. Buying, you could buy 2, 3, 5 terabyte hard drives for, $3 or something like that. No, you can't, but you get the idea. And that is a semi-valid argument until you realize that when you get into a real-world situation with these databases, databases are often replicated across environments. So if you've ever worked in a professional environment with respect to having applications and being programmed and having databases and whatnot, usually there's a development environment that the developers use. So a database is stored there. And then, first of all, I should say there's a local database that's stored on your local computer and nowhere else, so you can play around with it. So it's your own personal database. So it's there. And then it's replicated across the development environment, which is usually the environment that's available to all the programmers inside of the company. And then there's a Q&A environment, okay, a quality assurance environment that has, again, these databases replicated once again. And then sometimes there's a user acceptance testing environment where your users can use it as their playground to sort of test out new features and whatnot within your applications, and the databases will be replicated there as well. And then, you can even have, sometimes there's multiple instances of each of those steps. And then you have obviously your production environment, which is your live environment that's on the internet being used by real people in the real world. Your databases will be replicated there. Oftentimes, you have replication of databases with your reports. So if you have a reporting system, sometimes it's advantageous to create copies of the databases for those reporting type situations. How many is that? We're getting up to 5, 6, maybe even twice that to 12 copies of the same database. So for every one index that you create, you're potentially having to recreate that index 12 times over. Okay, and that, although space is cheap, when you multiply that by 12, it can get a little bit expensive. Okay, so you got to use indexes sparingly in the right situations. So then that begs the obvious question. Well, when should I use an index then? If we've just been talking about this and how good they are, now I'm a little bit scared about using them. So when should I use them? It's a difficult question to answer, this one, because there's obviously every situation will vary. But obviously there are ways that you can go about attacking this question to help you solve your problem. So the best way to attack this problem is to look at the slowest queries in your database. Okay, let's say you've built up your program, you've built up your database, you've built up everything, and it's being used in the real world, and you find that maybe your customers are complaining, or maybe you are not happy with how slow a particular area is in your application, or what have you. You need to look and find out which query in your database is the slowest. Now, I don't want to get into how to do that because there certainly are a lot of tools that you can use to diagnose and figure out where the bottlenecks are and where the inefficient SQL queries are. Those tools exist, so don't worry about that. So you need to find out where the slowest queries are. And then take a look at those queries. Okay, take a look at them and diagnose them. Also, another thing you can do is look at the queries that are run most frequently as well. Again, these are tools that you can use to find out what the most frequent query is within your application during its regular daily use. So let's say you've identified the most frequently run queries and the slowest queries. Now you need to break those queries down and look at one of two things, or rather two things. You need to look at the filters that are attached to those queries. So let's say, when I say filters, I mean the where clause, okay? So when you look at the where clause, you can see what are the columns that the where clause is looking at. So for example, the where clause that we're dealing with this entire time for this lesson was the amount column. So we were saying where amount is greater than 500, or where amount is equal to $1,000, or where amount is equal to $188, okay? It's always where amount. So that would be a very good indication that the amount column would be a good candidate to have an index on it. Okay, that's why I'm talking about indexing the amount column, because in the situation we were finding ourselves in today, we were always looking at where the amount column was greater than or what have you. Okay, so that's why I chose the amount column to be indexed. Also, you can look at the fields that are being selected. Sometimes you can have queries that don't just say select star from. Sometimes you have queries that say select, and then they give a handful of columns that they want to look at. And then it says from whatever table, where amount is greater than, so on and so forth. So you can look at the fields that are being selected as well. And if there aren't too many, or if there's one that's always being selected, you can infer that it's important, then that might be a good column to consider putting an index on as well. So if you constantly see queries where the amount column is in filters, then, like I said, consider adding an index on the amount column. Or if you are constantly seeing the same column being selected, so when it says select whatever from whatever table, when you say select whatever, the columns in there, if you see one constantly being selected, then you can consider that one for indexing as well. Okay, now I should throw in a little bit of a caveat here, and I'm going to show you this in a second. All primary key and foreign key fields, so your primary keys in your tables and your foreign keys pointing to the relationships from other tables, those are already automatically indexed. Okay, because those are very important fields, and those are fields that are going to be used very frequently, and MySQL realizes that because that's a universal truth, so it automatically indexes those for you. So don't worry about the key fields. All you need to worry about is the non-key attributes within your tables, and you should consider those as putting whether or not you should put an index on them or not. Okay, so having said that, let's talk about the types of indexes. Now I know we've talked about a lot already, and we're almost done here. I'm gonna switch into an actual example where I'm gonna show you how to create an index and whatnot. So we're almost done. Hang in there. So in MySQL, there are a few commonly used indexes. One is the primary key, another is a unique, another is index, another is full text. Okay, so primary key is something that you're already familiar with, and it's something that I just mentioned. Primary key is used to uniquely identify a row, and the actual value of the primary key field cannot be null. Okay, you can never have a null primary key. That is a universal truth because it needs to be able to uniquely identify a row. In any case, primary keys are considered a type of index because they are automatically indexed. Okay, so that's just a given truth that you need to accept and move on with your life. Another type of index is a unique index. Unique indexes are used to ensure there are no duplicates, but null values are allowed with a unique index. So if you can think about a unique index, a good example of using that would be on something like a username. So if you had a table, like a users table, and you had a username and a password and an email address or what have you, you would probably have a unique index or a unique constraint on your username field. Okay, that will not only will that help to constrain it to make sure that you can never have a duplicate, but it also helps with the speed of that particular column as well in terms of querying and whatnot. Okay, and then there's a regular old index, which is what we just used for our example today, which is where we were looking at having it in sorted order. You create an index. Creating an index is kind of like having a phone book. It sorts everything out. So a phone book is sorted by, last name? It's been a while since I've used a phone book. It sorts it by last name, or if you have like your contacts in your mobile phone, you can sort your contacts by first name or last name, depending on how you want to set it up. At least that's how I can on my phone. So that's exactly what it's like using. So it's sorting the data in some predictable manner so that you can flip through it quickly and get to where you need to get quickly. Okay, that's what an index is like. It's like a phone book. And then finally, there is the full text type of index. So a full text index is a special kind of index used for words, okay, for sentences, paragraphs, or singular words. You can think of it like taking the Google search functionality, the Google algorithm, and plugging it into your database. So your database, if you have fields, you have columns that store a lot of text, okay, then and you want that text to be searchable, then you would use a full text search index on your that database column, okay. So a good example of this is a program I created a little while back. It was a program that allowed you to interact with people on your website. Okay, so it was kind of like a chat program for your website. So let's say I built this website. Don't use this website. Let me think of. Oh, what's a good example? Let me think of how to program with Java.com. It's a blog that I created. So on howtoprogramwithjava.com, you would be able to, I'd put in a chat widget, And if you were on the website, you would see the chat widget pop up, and it would say something like, do you have any questions about the Java programming language? I'm really happy to help. Just type in your question, and I'll try to answer it for you. So the user would type in their question, and they would hit enter. And what would happen is that question would be automatically sent to my database, and it would check the database for my list of frequently asked questions. And if there was any sort of match between the question that they typed in and the questions that I had inside of my database, it would automatically show me on the other end some possible answers to that question. So before I've even looked at the question, the system has already figured out some possible answers to the question, and it just displays the answers to me. So I can read the question and say, okay, yeah, here's the answer. It's already found it for me. I'll just click on that and send it over. And the person on the other end is extremely happy because they've got an answer really, really fast. So that is an example of how you would use a full text index because it does that kind of, Google-like searching through your columns. Okay, cool. So now that we've covered those types of indexes and whatnot, now we can go forward with the real-world examples. Now, this video has gone on a little bit too long, so we're going to divide it into a third part where we're going to be talking about just that. We're going to look at the syntax involved, some examples, and just work on finishing up and polishing up our skills with indexing within MySQL. So, see you in the next part of this lesson. Bye for now.